Okay, today we're going to be looking at your green packet. We're going to be doing the last section of this chapter. It's page 13 and 14. The pages are actually out of order for some reason, so it's actually the last page front and back in your packet. So basically we're doing something that we've already learned, but I'm going to teach you a shortcut. Now it only works for what's called difference of squares. And what it's basically is when you have two terms, so I'm going to write this over here, two terms. It only works when it's a subtraction problem. And when you have perfect squares. Now what I mean by that is when you take the square root, you get nice numbers, okay? Now, just like any other time we factor, our first step is always to take out the greatest common factor if we can. So if I look at A, I'm just going to show you the process. If I look at A, I have two terms. I have a minus sign. Now, there's no greatest common factor here, right, besides 1. So what I'm going to do is I'm going to check to see if they're perfect squares. The way I do this is by taking the square root, okay? Now, if you're not sure what the square root of 81 or the square root of 16 is, in your calculator, if you hit Control and then the x squared button, you get the square root. So I can tell that 81 is a perfect square because the square root of 81 is 9. Same thing with 16. Now, you can't type in the letters, the variables. You can only type in the numbers. But the square root of 16 is 4. So, the square root of 81 is 9. The square root of 16 is 4. And anytime you have an even exponent for your variables, that's also a perfect square. The square root of anything squared is just the number, so it would just be c. So this is perfect squares. So what I'm going to do, the shortcut, instead of having to use the box method, is you make two parentheses. One's going to have a plus sign, one's going to have a minus sign, and literally in the same order that you see it, you're going to put 9 and 4c, 9 and 4c. So factored, this is 9 plus 4c and 9 minus 4c. So I know you're probably like, how does that happen? Okay, just to show you that it works, okay, I'm going to multiply this out and show you that I'm going to end up with what I started with. So remember, multiplying with the box method, we actually go on the outside and multiply to the in. So 9 times 9 is 81. 9 times 4c is 36c. 9 times negative 4c is negative 36c. And 4c times negative 4c is negative 16c squared. So I start with 81 because that's in the top corner. 36c minus 36c. 36 minus 36 is 0, so these cancel out. And I have minus 16c squared. So look, I ended up with this. Okay, so this is a shortcut. It's called difference of two squares. So if I look at B, right, the square root of 64 squared, or the square root of 64 is 8. The square root of g squared is g. The square root of h squared is just h. Now there were two terms and a minus sign, and these are perfect squares because I take the square root and I get nice numbers. So all I do is I make two parentheses. I have one plus sign, one minus sign, and I just follow the terms. So it's 8g and h, 8g minus h. So let's look at the next set. So C. This one, if I notice, I do have a greatest common factor besides 1. X cubed and x, I can take an x out. So I have 9x squared minus 4. So now I have two terms inside. I have a minus sign. I'm going to square root both of them to see if they're perfect squares. So again, if you're not sure if they're perfect squares, use your calculator. The square root of 9 comes out to be 3, so that's a perfect square, right? The square root of 4 comes out to be 2, so that's a perfect square. So this would be 3x, the square root of x squared is x. This would be 2. So I have two parentheses, one plus sign, one minus sign. I have 3x plus 2, 3x minus 2. Now don't forget about your GCF. We took out an x to begin with. So there's my answer. So if I look at D, again, I have a greatest common factor. I know that because my leading term is negative, and I can never lead with a negative. So I have to take that out. And then the y's, I have a y in common. So negative 4 divided by negative 1 is positive 4. And if I take out a y, I have 2 left. 9 divided by negative 1 is negative 9. And if I take the y out, right, I have none left. So now I look inside, I have two terms and a minus sign. I check for perfect squares. The square root of 4 is 2. Square root of y squared is y. Square root of 9 is 3. So I have 2y plus 3, 2y minus 3. Now the negative 1y I had out in front, I put that back in front. Now I didn't write the 1 out. You can if you want to. It doesn't matter. But there's my answer. Okay. So the you try. If you'd like to pause this, you can try it on your own, or you can just follow along with me. So if I look, there's no GCF here, but there's two terms and a minus sign. So if I take the square root to check to see if they're perfect squares, the square root of 36 is 6. Square root of a squared is a. 49, the square root of 49 is 7. Square root of b squared is b. So this is a perfect square. So I have 6a plus 7b, 6a minus 7b. Now f, this one I have a GCF. I can take out a 3 and an m. So 3 divided by 3 is 1, so I'm left with 1m squared because I took 1m away. 27 divided by 3 is 9, so I have the minus 9. And I took the m away, so I'm just left here. So now if I take the square root, the square root of m squared is m. The square root of 9 is 3. So I have m plus 3, m minus 3. Then I put the 3m out that I took out for my GCF. So there's my answer. So that is the idea of difference of squares. So that's a shortcut. Right? Now we can use difference of squares multiple times. So let's look at this. Here we have y to the 4th minus 1. So if I look, there's two terms and a minus sign. I told you anytime you have an even exponent, you can take the square root. The square root of y to the 4th is y squared. You're basically dividing the exponent by 2. Right? The square root of 1, if you put it in your calculator, it's 1. So what I have is y squared plus 1, y squared minus 1. Now the difference with this is, notice in the parentheses we still have exponents. If you still have exponents in your parentheses once you factor, you have to check again because you might be able to factor even more. Now this one, there's two terms, but there's a plus sign. So I know there's nothing else I can do here. But look here, there's two terms and a minus sign. So I can again check to see if I can do the square roots of these, if they're perfect squares. The square root of y squared is y. The square root of 1 is 1. So this can be broken down even more into y plus 1, y minus 1. The other parentheses that couldn't be broken down, I just bring it down. It can go in front or in back, it doesn't matter. And this is my answer. So I can do the same thing for b. This one doesn't have a GCF. It has two terms and a minus sign, so I'm going to check square roots. The square root of 16 is 4. The square root of x to the 4th is x squared. The square root of 81 is 9. So I have 4x squared plus 9, 4x squared minus 9. In my parentheses, there's still squares, so I check inside. Here it's two terms and a plus sign, so I can't do anything. Here it's two terms and a minus sign, so I check. These are perfect squares. The square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3. So this can break down even more into 2x plus 3, 2x minus 3. Then this, bring down the 4x squared plus 9. So here is my answer. So let's try a couple more. This one, the square root of a to the 4th is a squared. The square root of 625b to the 4th, that's a large number. But if I check, the square root of 625 is 25. So this is 25b squared. So I have a squared plus 25b squared. A squared minus 25b squared. We definitely have exponents still. This has two terms but a plus sign, so I'm done there. This has two terms and a minus sign, so I check for perfect squares. Here, the square root of a squared is a. Here, the square root of 25 is 5. The square root of b squared is b. So this can be broken down into a plus 5b, a minus 5b. This part here, we just bring down a squared plus 25b squared. And there's my answer. So D is the exact same thing. The square root of 256, again, if it's a large number, right, we can just check. The square root of 256 is 16. So I have 16. The square root of n to the 4th is n squared. So I have 16 plus n squared. Remember, we always go in the order that we're given. 16 minus n squared. This has two terms but a plus sign, so we can't do that. This one has two terms and a minus sign, so we check for perfect squares again. 16, the square root is 4. N squared, the square root is n. So I have 4 plus n, 4 minus n. Over here, I bring down the 16 plus n squared. And there's my answer. So let's just try this using different techniques. So here, I see a GCF, right? I can take out a 2. So if I do that, I'm left with x to the 4th minus 25. Now here I have two terms and a minus sign, so I check for perfect squares. X to the 4th, the square root is x squared. Square root of 25 is 5. So I have x squared I have x squared plus 5, x squared minus 5, plus that 2 that I took out originally. Now this one, I cannot go any further because even though it has two terms, it has a plus sign. This one, it has two terms and a minus sign, so I check perfect squares. The square root of x squared is x. The square root of 5, if you check in your calculator, that does not give me a nice number, so it's not a perfect square. So that means I can't break this down anymore. So that means my answer is just this. So I can't do perfect squares, or the difference of two squares, more than one time here. So if I look at B, 9 and 36 are both divisible by 9, and they both have an x in common. So I have a GCF of 9x. 9 divided by 9 is 1, and I take away one of the x's, so I'm left with x to the 4th. 36 divided by 9 is 4, and I take that x away, so I don't have any left. So I have x to the 4th minus 4. There's two terms and a minus sign, so I check perfect squares. Square root of x to the 4th is x squared. The square root of 4 is 2. So I have 9x on the outside, and then x squared plus 2, x squared minus 2. So again, now since I still have exponents, I'm going to check. This has two terms but a plus sign. This has two terms and a minus sign. The square root of x squared is x. The square root of 2, though, if you plug it in your calculator, is not a perfect square. It doesn't give you a nice number. So we were done here. So this is my answer. Okay. So if we look at C and D, these have 4 terms, so I can't use that shortcut. Right? I'm going to do the 4 terms like I normally do using the box method. But I do notice that for C, all of these numbers are divisible by 6. So I'm going to take that out first. So I have x cubed plus 5x squared minus 4x minus 20. Now it's ready for the box. So I have x to the third, 5x squared, negative 4x, and negative 20. Horizontally, I can take out an x squared and a negative 4. Vertically, I can take out an x and a 5. So I have x squared minus 4, x plus 5, and I have that 6 that I took out. Now, don't think you're done, because notice, this is new, right? But notice that we have 2 terms in here with a square. So if you have an exponent, you need to check to see if there's anything else you can do. There's 2 terms and a minus sign, so I can take square roots to see if they're perfect squares. The square root of x squared is x. The square root of 4 is 2. So this can be broken down into x plus 2, x minus 2. Now what happens to the 6 and the x plus 5? You just bring them down. So this is my final answer. So if we look at example D, this has 4 terms and there's no GCF. So I just go straight to the box. I have 2m cubed, m squared, negative 50m, and negative 25. Horizontally, I can take out an m squared. Horizontally here, these are both divisible by 25. So I take out a negative 25 because there's a negative in front. Vertically, I can take out a 2m. Sorry, this should be a cube. A 2m and a 1. So I have 2m plus 1, m squared minus 25. So I don't just circle and say I'm done, because I see that I have a square still in the parentheses. There's 2 terms and a minus sign, so I check for perfect squares. This is m, this is 5. So I have m plus 5, m minus 5. This 2m plus 1, I bring it out in front. There's my answer. Okay. So the next thing is perfect square trinomials. Since these are all trinomials, I don't think it's important to use the shortcut. We can just take out GCFs and use the box method. So we're going to skip that. So then we're going to look at the last example where it says now solve equations by factoring using these methods. So for A, I see that I need it to equal 0, so the first step is to subtract 25. So I have 4x squared minus 25 equals 0. There's no GCF. Now, again, if you don't want to do this, you don't have to. You can use the box method, right? We would just think of the middle term as 0x, and we would find something that multiplies to negative 100 and adds to 0. Right? You can definitely do it that way, but I'm showing you the shortcut. So there's 2 terms and a minus sign, so I can take square roots. The square root of 4 is 2, so I have 2x here. The square root of 25 is 5, so I have 2x plus 5, 2x minus 5. Now I set both of these equal to 0 and solve them. So this one I would minus 5 and divide by 2, so I'd get negative 5 halves. This one I would add 5 and divide by 2, so I'd get positive 5 halves. For b, I'm going to add the 81 to move it to the other side first. So I have 4x squared plus 36x plus 81 equals 0. Now this doesn't have a GCF, so I'm going to multiply its 3 terms. I'm going to multiply the 4 and the 81 together, and that gives me 324. So I need to find something that multiplies to 324 and adds to 36. I know those are large numbers, but it ends up being 18 and 18. So I make the box. 4x squared goes in the first one. My middle term splits into 18 and 18. And my last term is 81. Horizontally, 4 and 18, they're both divisible by 2, so I can take out a 2x. 18 and 81, they're both divisible by 9. Vertically, I can take out a 2x, and vertically here a 9. So I have 2x plus 9 times 2x plus 9 equals 0. Now if you notice, these are the same terms, so if I solve them, I should get the same answer. So I'm going to only solve one of them. I would subtract 9 and divide by 2, so I get negative 9 halves. So let's look at C and D. So C, 6 and 96, they are both divisible by 6. So I'm going to take out the 6 first. And I'm left with x squared, right? 6 divided by 6 is 1. And 96 divided by 6 is 16. So I'm left with x squared minus 16. Now in my parentheses, I'm still not done because I see the square. I have 2 terms and a minus sign, so I could use the box method, but I'm going to go for the shortcut. Square root of x squared is x. Square root of 16 is 4. So I have x plus 4, x minus 4. Now the 6 goes out in front, but when I solve, right, 6 equals 0 isn't going to give me anything. So I just use the x plus 4 and the x minus 4. So I get x equals negative 4. Here I get x equals positive 4. And the last example, right, I have 20c squared equals 60c minus 45. Technically, the fastest way to move this would be to move the 20c squared over, but then my first number would be negative. So instead, I'm going to subtract the 60c and add the 45 so that I can get the 0 on this side and that my c squared would stay positive. Now nothing over here would combine, so I have 20c squared minus 60c plus 45 equals 0. Now I have a GCF, they're all divisible by 5. 20 divided by 5 is 4. 60 divided by 5 is 12. 45 divided by 5 is 9. So now I'm ready for the box. I find something that multiplies to 36 and adds to negative 12. So that would be negative 6 and negative 6. So I make the box. I have 4c squared, negative 6c, negative 6c, and 9. Horizontally, I can take out a 2c and a negative 3. Vertically, I can take out a 2c and a negative 3. So I have the 5 that I took out, and then I have 2c minus 3. 2c minus 3 equals 0. Again, since these two parentheses are the same, if I solve them separately, I'm still going to get the same answer, so I'm just going to solve one. I would add 3 and divide by 2, so I get 3 halves. So again, you do not have to use the shortcut for difference of squares. It just will save you time if you recognize it. So if you do recognize it, you should use it. So now you need to go to your pink packet and do the homework that pertains to this section. The sub will tell you what pages those are. I'll see you guys tomorrow.